Hey, welcome to Dr. Pat TV. I'm looking at this concept of average rate of change. All right, so one of the things to be thinking about when we're doing average rate of change, hopefully you'll be thinking this key word right here, slopes. That's really what it is. It's slopes. It's the slope between 2 points. That's what we're talking about. So the slope between 2 points on a graph, on a curve, between 2 points of a function. Okay, so that's the key thing on average rate of change. It's about 2 points. That slope between 2 points. Not about 1 point, because 1 point is instantaneous rate of change. It's tangent. We're talking about between 2 points. All right, so let's take a look and see what we got. I'm just going to use this idea, having fun with it, so please bear with me. So I'm just going to use this idea about, hey, we've got this complaints from students about this professor who is just putting people to sleep. It's just, droning on and on and on and not making it interesting and not getting people active and involved. So the students complain to the dean. The dean comes and watches, and the dean starts recording the percentage of students who have fallen asleep. So that's what's happening here. At any particular time, what percentage of the class is asleep? So that's what we're looking at here. Okay, so we're looking at what percentage of the students are asleep. And so now the question becomes, meets with the professor and the dean get together, they meet, they talk about the class. The professor's not going for it because you know how sometimes professors can be, and so wants to defend himself or herself. And so if I'm the professor, how do I defend myself? Okay, now one of the ways that I could defend myself and say, hey, look, dean, I'm actually doing a decent job. The reason being is because the students are falling asleep at a very small rate. A rate of something like only 0.5% per minute. Okay, you might be thinking 0.5% per minute, so that's not too bad. That would mean like at the end of 50 minutes I might have 25%, a quarter of the class may be asleep. So it surely doesn't look like this graph. So how is the professor coming up with this? All right, so I'm just kind of playing along with it. Bear with me. And so this is the statement. It's only 0.3%. 0.3% is what I'm using to defend myself. And just remember, rate is the same thing as slope. How could I make this statement and actually this is really a true statement. I'm not lying to you. Because, as I defend myself, I'm a math person, so I'm going to defend myself with the numbers, with the calculations. And that's a true statement. Now, how did I do that? Here's how. I started here. I picked this first point, and then I picked this as my second point, and I found out, hey, Dean, I've just calculated. I got a rise of 15 and a run of 50. I do that calculation, and it turns out to be 0.3% per minute. So that's all that's fallen asleep is just a mere 0.3. Okay, so what's going on here? Well, we can see this graph is increasing like crazy. Students are falling. I mean, the graphs tell a story. Students are falling asleep, and they only start waking up. Remember, this graph is decreasing here. That's actually meaning students are waking up, because for the increasing, that means more students falling asleep. And then when this graph decreases, that means students are waking up. And clearly, we all know why students wake up at the end of the class period, because everybody else is starting to get ready to go. So noise starts being made from, seats next to you. And so people start waking up. But by using this slope right here, this rate of change, I like to use the word overall because it starts from time zero. That's just a very specific type of description. This is also an average rate of change, just happens to be one that starts at time zero. That's all that is. And so that is how we can use rates of change. This is how a professor can use it to defend themselves, saying, hey, no, overall, my rate of change is actually pretty good. This is actually, somewhat decent. So what do we got to do here? All right, so you might be thinking, dude, that was just made up. Thanks for the example. But notice the shape of this graph right here and the one that I was playing with. It's kind of got that same shape to it. And so you might see this in the stock market. Okay, this was during the Not currently, but about back 10 years ago in that sense when we were having our own little recession then, and stock market went down. We actually, a investor could actually say, it's actually not so bad because over the years I've had a $134 gain per year if you used the point at the beginning here and this point at the end. And if you skip everything else, so remember this 2 points right here, this line doesn't really follow the data very well. It ignores all these ups and downs. And so using these two data points as our rate of change really does describe the situation incorrectly, kind of misses all that information. But in the same way that a professor can say my students are not falling asleep, and an investor can say no, 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 even though we had a big downturn here, where even though the slope is really big right here, I could be trying to keep you as my client, saying no, no, I've been able to make sure that you've gained money for this whole time period. So when you're investing, when you're working with your financial investor, make sure you really understand what it means, these values, these rates of change, the year to dates and all those kind of things, because we're using rates of change in many ways. And one of the key things about rates of change is the interval that you're using. What's your beginning and ending value? And then a rate of change is an average that goes through there, and it may miss a lot of information. It kind of whitewashes that all out, calms it all down, but you could be missing information. So it's one of the careful things we got to be about our rates of change. Okay, so another way that this professor can say is like, no, wait, Dean, if you don't believe my first story, I've got another way to explain this. And this is using a combination of rates of change. Now, remember, we're talking average rates of change, just slopes. And so with the professor I as a professor myself, I can say, hey, Dean, students are coming. It's after lunch. It's a 12:30 class period. People have just eaten lunch, and just like anybody else, people get tired. You got a nice full belly. People are tired. They're going to start falling asleep, and it's not my fault because people are falling asleep. They're coming in that way. So maybe for the first 10 minutes, you can say that, dude, not my fault. That's the way they are. They're coming in tired. Or maybe it's an early class period. People are still waking up, that kind of stuff, getting out of bed. Okay, but then the professor's saying, but after that first 10 minutes, notice what happens. I've got a slope here of 0. That means on average for the next 40 minutes after I have, the lunch is worn off, after I've had an impact, I've got a slope of 0 and nobody falling asleep. Once again, it is a true statement in terms of the slope right here, the rate of change. But once again, when we're talking about rates of change, an interval of 40 here, going from 10 to 50, that's an interval of 40, you can lose a lot of information. It doesn't incorporate, rates of change doesn't incorporate that piece of information. So you want to be careful about that kind of stuff. Okay, so here's an example of using this. Now, how do we get around that? Okay, let me pause for a second. Now, the way the dean should respond is this type of situation. So on the previous example, I had an interval of 40. Well, that's 40 minutes out of 50-minute class period. That's a big chunk of the time. So in order to get a better idea of what's happening, the impact of this professor during the class and students falling asleep, what we want to do is do smaller chunks of time. Make the average rate of change go over maybe a 10-minute interval. So we've got 5 chunks of time periods here, or maybe even smaller and do 5 minutes. So what's happening here is, if you want a better idea of what's really happening around, throughout a time period to describe a situation, you might want to use rates of changes for smaller time periods. And in this case, what we're really seeing is we're increasing here, increasing. And what I mean by increasing is that all of these slopes are positive. They're as we go left or right, they're getting higher. And so that is clearly saying there is something going on in this classroom. And the only time that this graph, this rate of change, that we have a negative rate of change, is only here at the end, when the students are waking up and they're getting ready to go to another class and stuff like that. So, just wanted to do a quick little example of how you could use rates of change in the real world. Take care and see you on the next one.